Hello, my name is Antonio Navarro Duran, and in this video I will talk about the problem situation of the formation unit Q1021. Oil is very important for the world, but it's becoming scarcer, costlier, and a major environmental pollutant. As a result, automotive companies are exploring alternative energy sources to reduce these issues. The project involves creating a galvanic cell to use as a voltage source to power the motors of a small electric car. The galvanic cells, that are also called voltaic cells, are electrochemical devices that convert chemical energy into electrical energy through a spontaneous redox reaction. They consist of two electrodes, one called anode and the other one called cathode, that are immersed in an electrolyte solution that is connected by a salt bridge and an external circuit. In this case, the cell consisted of a copper sulfate solution in which the electrodes, which were magnesium and copper, were immersed. To obtain the necessary voltage, two of these cells were connected in series. To understand how the cell works, it's important to analyze the reaction. We observe that magnesium changes from a metallic state to an aqueous state, which is reflected in the loss of electrons. It is therefore the oxidized state, and therefore the anode. Copper changes from an aqueous state to a metallic state. That is, it gains electrons and is therefore the cathode. It is important to clarify that copper sulfate was used for the solution because in a galvanic cell, the solution must always contain a salt of the metal from one of the electrodes. To calculate the voltage the cell will generate, we must use the reduction potential chart, in which the higher the elements are, the easier it is for them to be reduced. By definition, we note that in a spontaneous cell, we must subtract the anode potential from the cathode potential. So we'll look at the chart and see that the anode, in this case magnesium, is minus 2.34 and the cathode, copper, is 0.34. Performing this calculation, we find that the cell potential is 2.71 volts. To calculate the amount of salt needed for the solution is 15 milliliters and the molarity is 1.5. The molecular weight of the compound can also be obtained from the periodic table. Now, the mass of the solute is solved from the molarity formula, and it is obtained that the required grams of copper sulfate are approximately 10. This was the final result of the car. Each cell measured approximately 2.6 volts. In conclusion, the development of clean energies can be very useful, since it can be applied to situations such as that of the car.